everybody, today we're continuing our videos on transformations. So we've already learned about vertical stretches, compressions, and reflections, as well as translations, both left and right and up and down. But today we're going to learn about horizontal stretches, compressions, and reflections. Okay, so this video focuses strictly on that. So when we talk about a horizontal stretch, compression, or reflection, it comes from the parameter k. So the k value is a parameter that's kind of k is inside the function. So k is something that is multiplied by x wherever x is in the function. So first you need to be able to recognize where k is. So for instance, if k is equal to 2 and you have the parent function x squared, then the 2 would go in here with x in brackets. Okay, this is different than if we had 2x squared. Okay, because in this case, the a value would be 2. Since 2 is on the outside of the function, it's multiplying the x squared. Okay, so the 2 is not being squared. Whereas here, 2 is a k value because it's within what is being squared. So it's within the function. So it's next to x. Okay, so for 1 over x, the k value is here, 1 over 2x. So again, it's together with x wherever it is in the function. For root x, it's under the square root. And again, as opposed to if we had to root x, in this case, this would be an a value, which would be a vertical stretch or compression. But in this case, it's under the square root, so that's a k value. It represents a horizontal stretch or compression. And then finally, with absolute value, your 2, again, is on the inside of the absolute value symbol there because it's inside the function. Okay, so that should help you identify which value is k when you're looking at a function. So let's do some investigation. Let's do some investigation to figure out what the difference is between a vertical stretch and compression and a horizontal stretch or compression. So we're going to do this with root x, and first we're going to look at the value 2. So fill out your table of values just for root x. So when you put in 0, you get square root of 0 is 0. When you put in 1, you get 1. When you put in 4, you get 2. When you put in 9, you get 3. 16 is 4 into the square root function. Now notice my x values do not go up by 1. I didn't do 1, 2, 3, 4 because root 2, for instance, it's not a pretty point. Root 2 is a fraction, and so it wouldn't look nice on our graph. So I picked the x values that I know would give me integer y values. That's what I did, and that's what you should do as well anytime you're doing a square root function. So I picked these points that I knew looked pretty on a square root graph, and then use just a basic color to graph your root x function here. Thus is y equals root x. So 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. So if you need to pause the video, make sure you get that all set and you know what's going on there. Okay, so now we're going to look at 2 root x. So 2 root x is what we did in the previous video. Okay, this is an a value of 2. So it's going to be a vertical stretch by 2. Okay, we already know that from our previous video. So think about it. When we put 0 into the function, square root of 0 is 0, so 2 times 0 is 0. We put 1 into the function. Square root of 1 is 1, 2 times 1 is 2. Square root of 4 is 2, 2 times 2 is 4. Square root of 9 is 3, 2 times 3 is 6. Square root of 16 is 4, 2 times 4 is 8. Okay, so here we can see that the y values are multiplied by 2. Okay, if you compare this to here, you can see for the same x value, all of the y values are doubled. And that's because you're stretching vertically by 2. So visually, what does this look like? Okay, I'm going to use red to represent this function. So if you have other colors, you should get those out. Okay, so I have 0, 0, 1, 2. So this was only one high before. Now it's twice as high. Here, this point is 2 high, so now it's going to be doubled, the stretch by 2, to become 4 high. So this point here was 3 high, and now it's going to be 6 high. And this point was 4, so that y value will be doubled to go up to 8. So here you have y equals 2 root x. And there you have it. Just going to turn this light on. It's a bit dark. Okay, so now we're going to do root of 2x. So notice that I left some blanks here. I did that on purpose. You'll see why in a minute. So first, let's just fill in the same x values we had before. 0, 1, 2, 9, and 16. Well, in this case, notice we put 0 in. We multiply 0 by 2 before we take the square root. But that's still just 0. Okay, fine. So now we put in 1. Well, 2 times 1 is 2, and root 2 isn't a nice integer, so we're just going to leave it as root 2. Okay? We put in 4. 2 times 4 is 8. We have to do the multiplication first. So then we get root 8. Again, not an integer. Not very exciting. 2 times 9 is 18, so root 18. 2 times 16 is 32, root 32. Okay, I don't want to graph this. It looks disgusting. Okay, I don't want to have to graph roots because they're decimal values, and I don't know exactly where they fall. It's not going to create a good looking graph. I mean, I can do this. I could turn these into decimals, approximate where they go. You know, it wouldn't be awful, but that's not really the best way of going about this. So let's think about this a different way. So what if we want to get the same y values that we did before? So here, I have a y value of 1. So how do I get that y value of 1? What value do I have to put in there so that I get a 1 that comes out of it? So 2 times what equals 1? A half, right? So if I put half into this function, I get 2 times a half is 1. Square root of 1 is 1. Okay. Now I want the y value of 2. So to get a y value of 2, I need to take the square root of 4. So what x value do I put in here so that I'll be taking the square root of 4? Well, 2 times 2 is 4, so x needs to be 2. Okay? Now I want the y value of 3. Okay? So for this to be a 3, I need to take the square root of 9. The square root of 9 is 3. That's what I want. So to get 2x to become 9, x has to be half of 9, which is 4.5. Okay? Or you can keep it as 9 over 2. Actually, I'll do it as 9 over 2. You'll see why in a minute. Okay? And then I want my y value of 4. So to get 4, I need this to be a 16. So 2x equals 16. I need my x to be 8. Right? Because if I do 2 times 8, that's 16. Root 16 is 4. Okay, so these are better points that I can more easily graph. So let's compare them, okay? So here is our y value of 0, and here it is. Okay, we're just comparing to this part here, okay? Here is my y value of 1. Here is my y value of 2. Here's my y value of 3. And here is my y value of 4. Okay, so 1, 2, 3, 4. Now, let me remind you that all of these points are legitimate points that you could plot. It's just that these have nice integer y values. So let's compare this to this. So what do you notice about the x values that have the same y values? Well, they both have an x value 0 for 0. Okay, nothing exciting. Okay, this one has 1, and this one has a half for 1. This one has 4, and this one has 2 to get 2. This one has 9, and this one has 9 over 2 to get 3. this has 16, and this has 8 to get 4. So what's happening here is that the x values are divided by 2. Okay, so what does that look like? So if I go to sketch this, we'll do orange here. Actually, I'll do green to show some contrast. So instead of my point being 1, 1, it's now a half 1. And instead of being 4, 2, it's now 2, 2. And instead of 9, 3, it's 4 1/2, 3. And instead of being 16, 4, it's 8, 4. So here, so I don't know if you could tell what I was doing there, but you'll notice that if you compare the black points to the green points, instead of looking what's happening vertically, look what's happening horizontally. They're all being compressed by a half. So all of the x values are a half of where they used to be, okay, including here, even this little guy, okay? And the y values, if you look back at 2 root x, this was a vertical change where we're doubling. So in this case, they were all being doubled. But here, actually, you should really just put arrows on this end to show that they're going from the black to the green. Okay, so what we can conclude then is that a k value of 2 actually gives us a horizontal compression by a half. All the x values are half as far out as they used to be, okay? As opposed to an a value of 2, which gives us a vertical stretch, so the y values are twice as high as they used to be. So, to get the same y values, the x values are compressed by a half. They're half as far out as they used to be. So I know I'm repeating the same thing over and over again, but I'm hoping that you're writing things in the margin or giving yourself any hints to help you understand this. Okay, so our conclusion there is that a k value of 2 led to a horizontal compression by a half. Okay, and that's because the x values that we had to put in had to be as half as big as they used to be, so that when we doubled them, they got back to where they were supposed to be. So for instance, when we want root x to be 16, normally we just, put in 16 and we get 4. But now we have 2x and we want that to be 4, the same y value. So in order for that to work, you have to put in half of the x value as you did before. You have to put in 8, not 16, because then you double it before you square root it. So it's kind of opposite thinking as the vertical stretches and compressions. Okay, so 9. Normally to get 3, I just put in 9, root 9 to get 3. But now if I have 2x, when I take that square root, I still want it to be 9, but now it's 2 times x, so that x has to be 9 over 2, half of what it used to be, so that when I double it, I get back to 9. So let's turn the page and look what happens when our k value is now a half. So you might have a guess, or a conjecture, as we would say in mathematics, as to what is going to happen here. Okay, so again, take some time to sketch just root x. Okay, fill in your table of values, sketch it, understand why I chose those points and not just 1, 2, 3, 4 for my x values. Okay, so pause, make sure that's all good. Okay, so now let's do the a value of a half. So here a is equal to a half, right? So basically all these y values are going to be half of what they were here, okay? Because we're putting in the x value and you're getting out the same results, but then you have to have it, okay? All right, so what is that going to look like? So we still have 0, 0. Okay, but our 1 here is it's half of where it's supposed to was up before. Now this at 4, 2 is going to be 4, 1. This at 9, 3 is 9, 3 over 2, or 9, 1 1/2. and 16.4 is going to be 16.2. So again, that is what we've already learned. That is should go through that point. That is a vertical compression. So that is y equals a half root x. So notice the half is outside the root. Okay, so all of these are being pushed down, squished down to a half of what they used to be. That's what that a value of a half does. But what about a k value of a half? So here k is equal to a half. Okay, so it's going to be similar to what I did before. I'm going to write in black just because I'm worried you won't be able to see the green, and then I'll sketch in green. So remember, you have to apply the half before you take the square root. So a half times 0 is 0, root 0, 0. Okay, we're good. So a half times 1 is a half, so this gives us root of a half. Okay, a half times 4 is 2, so root 2. A half of 9 is 9 over 2, so this is root 9 over 2. Okay, and then I had 16 down there somewhere, but we don't even really need it. So